In this video, we'll discuss how to find the amortization payments and also the remaining balance for loans such as a mortgage or a car loan. Now, a loan is amortized if both the principal and interest are paid by a sequence of equal periodic payments. Now, suppose you have a loan of P dollars at an interest rate of I percent per period, which may be amortized in N equal payments of R dollars at the end of each period. So you're borrowing P dollars, where R is how much you'll have to pay each period, I is the interest rate per period, and N is the total number of payments you're going to have to make. Now the formula for R is equal to P divided by the quantity 1 minus the quantity 1 plus I raised to the negative N, all divided by I. Now, dividing by a fraction is the same thing as multiplying by the reciprocal, so let's multiply the P times the reciprocal at the bottom. So we'd have P times I all over 1 minus the 1 plus I raised to the negative N. Now remember, I is the same thing as R, little r over M, where R is the annual interest rate, M is the interest, or the number of times compounded per year, and then N, the total number of payments, is equal to little m times T, where M is equal to the number of times compounded per year, and T is equal to the number of years. Now in this example, John buys a used car costing $6,000. He agrees to make payments at the end of each monthly period for 4 years, and he pays a 12% interest compounded monthly. Now the question is, what is the amount of each payment he will have to make? Now for this problem, P, the present value, which is the current value of the car, is $6,000. The annual interest rate, R, is equal to 0.12. M is equal to 12 because it's compounded monthly, so we'd have 12 periods in a year. And T is equal to 4 because it's for 4 years. Now this means that I is equal to 0.12 divided by 12, which would be 0.01. Now N would be 12 times 4 because there would be 48 payments that he would have to make within the 4 years. Now plugging those into the formula, we get that the payments would be 6,000 times 0.01 all over 1 minus 1 plus 0.01 raised to the negative 48. Now again, the 1 plus 0.01 would be 1.01. Now plugging that all into the calculator, we would get 158.0030126 ... because it goes on forever. Now rounding this to the nearest cent, we get that John would pay approximately $158 each month. Now to figure out how much interest John will pay, well, we'll figure out how much he'll pay total and subtract off the present value of the car, so we subtract off the $6,000. So what we get is, well, he made 48 payments of $158, and subtract 6,000 from that, you get $1,584. That's how much he would pay in interest. Now suppose John came into some money after a couple of years and he has enough to pay off the remaining balance. How would we figure out how much is the remaining balance? Now if a loan can be amortized by N payments of R dollars at an interest rate of I per period, then the approximate remaining balance, let's call it B, after X payments is given by the formula B is equal to R times the quantity 1 minus the 1 plus I raised to the negative the quantity N minus X, all divided by I. Now it's best to see this with an example. Now from our previous example, let's suppose that John wishes to pay out the remaining balance after 2 years. And we want to know how much is the remaining balance, how much would he have to pay? So for this example, the payment amount that we figured out previously is 158. The total number of payments was going to be 48, but X is the number of payments he's already made. Well, they've already made 24 payments because after 2 years. And then the interest rate per period is still 0.01. So plugging those into the formula, we get 158 times the 1 minus 1 plus 0.01 raised to the 48 minus 24 all over the 0.01. So that would be 158 times the 1 minus 1.01 to the negative 24, because since we made 24 payments, there are still 24 payments remaining, all over 0.01. Now plugging that into the formula, we get into our calculators, we get 3,356.455. Now you might be thinking, wait, isn't it after half the year we've paid off half of it? No, because a good amount of the initial amount from our payments was actually going off to paying off interest. So that's why you don't actually have half of it paid off after half the amount of time. So the remaining balance in this case, rounding it to the nearest cent, would be $3,356.46.